All right, hi you guys. Today we're looking at lesson 3.2, which is the sine law. So if you remember last time we looked at kind of a recap of Math 10C, where you would have learned the properties of right triangles, so triangles that have a 90-degree angle in them. And remember that with those kinds of triangles, we could use Pythagoras to solve for a side, or we could use any one of our trig functions, sine, cosine, or tangent. Now, what we want to be able to start doing in Math 20-2 is being able to solve triangles that are not 90-degree angles, because obviously not all triangles have a 90-degree angle. And so in order to do that, these kinds of triangles are called oblique triangles. And basically what we're doing is working with this thing called the sine law to start with. We'll look at another law a little bit later. So the sine law, which is essentially a comparison of the ratios between the sides and the angles. So if we look at side A of a triangle and compare it with sine of angle A, that ratio between those two values is going to be equal to the ratio between side B and the sine of angle B, and then the same thing for side C and sine of angle C. Okay, now one thing to be aware of is that this version of the sine law is on your formula sheet. You can actually invert all the parts of the sine law so that you have sine of the angle on top and the side on the bottom of the ratio. This is not given to you on your formula sheet. It's not super important for you to memorize this. The only thing that this does for you is sometimes it can make the algebra that you need to do a little bit easier. Now, unfortunately, I already started drawing on this because I tried to start on this video and then the whole video system started glitching out. So basically what I wanted to go over as well is just a reminder. We looked at it a little bit last time, but remembering how you label a triangle. So essentially, if you have an angle, it's always represented with a capital letter, and the side that's exactly across from it is always the same letter as the angle but in lowercase. Okay, so angle A goes with side A, angle B goes with side B, and angle C goes with side C. Okay, so let's look at how we can actually use this sine law, because when you just look at it like this, it kind of looks maybe a little bit confusing or even kind of scary. So we're going to use this triangle to solve for the measures of A and B. So remember, A and B are sides. So if we have angle A, side A is going to be directly across from that. And if we have angle B, side B is going to be directly across from that. So if we want to start solving for those, we have two angles and we have a side. So what you always want to do with the sine law is, because each kind of part of the ratio involves an angle and a side, you want to try and make sure that one of your measurements involves a known angle and a known side. Now in this triangle, we only know side C, which doesn't correspond to a known angle. But keep in mind, if we already have two angles in a triangle, what other method do we have for solving for angles? Well, the first thing that we know is that side C is going to be whatever is required to make up 180 degrees together with these two other angles. So we can solve for angle C really easily by doing 180 degrees, which is the total degrees in a triangle, and then subtracting off the existing angles, so 75 degrees, and 26 degrees. Okay, and when we do that, we end up with, what did I get for that one? Sine C, 79 degrees. Okay, so right here we have 79 degrees as our third angle here. So now we have angle C and side C. If we want to solve for, let's start with side A, we have angle A. So if we look at filling in our sine law, we can fill in, we have an unknown variable here, we have a known here because we have sine of A, which is given, we have a known variable there, and we have a known variable there. So as you know, if you have any kind of algebraic formula or equation, if you only have one unknown, you can solve for it. So now we basically just need to fill this in. Now, the one thing I'm going to kind of give you guys a little bit of a hint with is, actually, you know what? I'll do that on our next one. For now, let's just use just the one, like just the formula that's on our formula sheet. So we'll start with side A over sine of angle A, which is 75, is equal to side C, which is 12, divided by angle C, which is sine of 79 degrees. Okay, so if I want to solve for this unknown, both of these number values here we can solve for. So all I need to do is multiply this sine 75 away from the A. So I'm going to have A is equal to sine 75, and then I want to multiply it by 12 over sine 79. Okay, and when I do that, I end up with A is equal to 11.8. And because we don't have any units, we can leave our answer as that. All right, so the other side we needed to solve for was side B, and we're going to use the exact same method here. So it's going to be side B over sine of B, which is sine 26, which is equal to, and then again you want to use a known value, but remember, like I mentioned, you want to try and use the values that you know or that you were given first of all, just because that will improve your chance of being accurate. Now I know we did calculate angle C, so you might say, like, why wouldn't we just use A? But it's a lot less likely that you would have made a mistake subtracting these numbers to get this angle than that you would have made a mistake doing solving for side A, because side A involved both angle C, which you calculated, and then further calculations. So I'm going to use side C again, which is 12 over sine of angle C, which is sine 79. And as you can see, the math is the same. We just need to multiply this sine 26 away from the B. So we're going to have B being equal to sine 26 multiplied by 12 over sine 79. Okay. And so when you do that, now just really quickly to show you guys, like I've been trying to keep up with here, is making sure you're putting in good order of operations. So essentially all you would do is sine 26, and there's like a couple of ways you could do this, I guess. Personally for me, what I would do is sine 26 and then enter that. And then, just because I like keeping things all together, 12 divided by bracket sine 79 bracket. Oh, I don't know why I put a bracket there, but that shouldn't affect it. And then that times by the first answer that I got. That gives me 5.35, which is the correct answer. So I can say B is equal to 5 point, let's just round that to 1 decimal point, so 5.4. Okay. All right, so again, I encourage you to try these in your calculator to make sure that however you choose to put in your order of operations, you're getting the same number, because then you'll know that the method you're using is going to work consistently in your calculator. Okay, let's try another one here. So using the diagram to the right, find all missing sides and angle measures. So remember from last time, the other way that this could be written is solve this triangle, right? And solve this triangle always means find anything that's missing that's not given. Okay, so we have angle A. First of all, you always want to label your sides so that you can keep track of how you're using your sine law. So angle A here, right across from it is going to be side little a. Here we have angle C, so right across from it is going to be side little c. And then angle B, right across from it is going to be side little b. Okay. What are we all missing? Well, we're missing side B, and we're missing angle A, and we're missing angle B, so we need to solve for all of those. Okay, So let's kind of think about where we would want to start. Now, it's difficult to start by solving for the two angles. Like once you have solved for one of these angles, then you can start using the 180 minus the two angles. But first we need to get one angle. So we need to start out with that. So let's maybe start out with angle A because it's the first one. So if we want to look for angle A, now what you might have noticed in this previous page here, oops, sorry, I'm flipping back to the previous lesson. What you might have noticed in this previous page here is that when you have like the unknown variable on top of your function, it's a lot easier to solve for it, right? Because you just have to multiply the bottom away. If you remember in our last lesson, we talked a little bit about how tricky it can be when you have to, when your unknown is on the bottom and then you need to multiply it away and divide the other side out. And so if we're looking for, if our unknown in this triangle is an angle instead of a side, this is where this second version of the sine law can kind of come in handy. Okay, so let's try using the different version of this to solve for an angle. Okay, so for angle A, we're going to say sine of angle A divided by, we have the opposite side here, which is A, 17. Okay, is going to be equal to, now we need to figure out which other one we want to use. The only other one we have where we have an angle and a side is C. So we want to do sine of angle C, which is 105, divided by side C, which is 37. Okay. Now, one thing that I kind of showed you guys on the filled in, oops, this is kind of getting a little bit out of the screen. One thing that I did show you, want to show you guys, or that I had on the like filled in copy of the notes that I posted, is depending on where you're at, you can use cross multiplication. So I want you guys to understand how the algebra works like that. You would multiply this to the other side. But if you want to just like as a quicker backup use cross multiplication, remember cross multiplication is always going to be the two number values that are diagonal from each other multiplied together and then divided by this last one. So if you want, you can use cross multiplication. So basically you would have sine A is equal to 17 times by sine 105 divided by 37. And this is the same as like number values that you would get if you just rearranged it algebraically. But I know some students really like the cross multiplication, so I just wanted to walk through it one time. In the future, I'll just keep on going with the algebraic solution. So 17 times by sine 105 divided by 37 gives us 0.44. So do you think that that seems like it'd be a reasonable value for this angle? Do you think that if this angle is 105, this could be less than 1? No. Usually we're not going to see angles that are less than 1. So when you get a decimal, that tells you that, if you remember last time we talked about whenever you're solving for an angle and you're using trig, that means you have to do the inverse of the trig function to actually get the angle, because this is, I don't know how to say that exactly, but like basically the algebraic opposite. So what we want to do to solve for just A, because we're saying sine A is equal to 0.44. So if we want to solve for just A, the algebraic opposite of sine is sine minus 1. And then we have to do that of 0.44. So by doing sine minus 1, it's kind of like the same as what we're doing when we multiply something that's being divided over to the other side. This is the opposite operation of sine, and that's how we move it away from angle A. Okay, so we have sine minus 1 of 0.44, and that's going to give us angle A being equal to 26.3 degrees. Okay. Now what else would we have? Okay, so if we have angle A, now the only other missing angle we have is angle B, and we know, like I mentioned earlier, that's going to be really easy to solve because we know that the angles need to sum to 180. So I can do 180 minus 105 minus 26.3. Now, this is one of the kind of weird exceptions where if you've given an angle and it has like, you give it to say a tenth of a decimal place, in the past I've told you like don't round for your next place where you're using that, but because the decimals get so prolonged with angles, if you're doing the 180 minus minus, this is the one instance where you can just use the answer that you concluded here so that you get the exact number that's going to add to 180, right? So if we put in minus 26.3, we get angle B is equal to 48.7. And you can even tell, right, with the 0.7 and the 0.3, that's going to add up to a whole number. And then if you add those all together, you should get the full 180, which is what we want to have. We never want to have decimals throwing off our angle measurements. Okay, so this is the one time when you can just do your rounding and use that rounded number. Okay, so then the last thing we need to solve for is side B. So again, if we're solving for a side, you want to use the version of the sine law where the side is on top. So little b over sine of angle B, which was the 48.7. And that's going to be equal to, now again, remember you want to set it equal to the one that you already had the most information given initially, which is C and C. So we're going to do 37 over sine 105. Okay, so cross multiplication would be sine 48.7 times 37 divided by sine 105. Algebraically, what we're looking at is sine 48.7 times by this whole thing. So we can say B is equal to sine 48.7 times by 37 over sine 105. Okay, and so that gives us, let's see, side B being equal to 28.8. And because we were given units of measurement for these sides, we want to maintain that in our answer here. So cm should be in there. Okay, so there's our final answer for that one. And you also always do kind of want to think a little bit like if it seems like it could make sense. Like if this side is 17, this side is 37, does it kind of make sense that this could be close to 30-ish? Yeah, it looks approximately reasonable, right? We didn't get a number like 70 or something crazy, because then you know that you're on the wrong track, because there's no way that that would seem reasonable. Okay, so it is always a good idea to kind of evaluate whether you think roughly that your answer makes sense. Okay, so using the diagram to the right, find angle B. Okay, so in this one we're given angle A and side A. So that's what we need for our sine law, is an angle and a side. And we're just looking for angle B, and we already have side B. So this one's going to be pretty easy. The only thing we need to keep in mind is which version of the sine law do we want to use. So remember, if your angle is what you're looking for, it's easiest if you use the one with the angle on top. So sine B over side B, which is 2, is going to be equal to sine A, which is sine of 30 degrees, over side A, which is 1.5. Okay, so sine B then is going to be 2 times by sine 30 over 1.5. Okay, and when we do that, we get sine B is equal to 0.6 repeating. If you're not familiar with it from previous math, just make sure you're aware that whenever you see this flat line over top of a number that's after the decimal, it always means that that's repeating. So in your calculator, you probably got 0.6666666, and then usually your calculator rounds the last one to a 7. So this is an easy way of writing that out without having to write out all the 6's. Now remember what I mentioned, usually you're not going to find an angle that's less than 1. And if you look at the fact that this is a 30-degree angle, it definitely wouldn't make sense for that to be a 1-degree angle, right? Or a less than 1-degree angle. So remember, to solve just for the angle, we need to do the opposite operation of sine. So that's going to be sine minus 1, which moves it to the other side of 0.6 repeating. And so from that, we can calculate that angle B is 42 degrees. Okay, so hopefully the sine law is starting to seem relatively straightforward for you, but we'll try a couple more examples. Let's see, what is this? So these ones are a little bit trickier because you have to draw the triangle yourself. So it says find the solution for each of the following triangles. So remember, find the solution or solve means find all of your missing sides and angles. With these ones, it's going to be a little bit harder to kind of estimate whether your numbers are correct because you're drawing it yourself. And so usually, like, unless you're going to sit there with a protractor and measure each one and the sides, it's not going to be an exact drawing. So I usually just kind of sketch out whatever. I don't really worry too much about what the measurements are. So I've got a triangle, and I'm going to go A, B, C as my sides, or sorry, as my angles. So then I've got side little b, side little a, and side little c. And it tells us that angle B is 56 degrees. Side C is 10 centimeters. So C equals 10. I'm not going to include the units in the drawing just so that I'm not getting messy in there. And then side B is 12 centimeters. Okay, so I need to solve for everything that's missing. So right now I only have one angle, so I need to solve for another angle before I can solve for the third easily by using the 180 degree kind of rule. So let's see, we have, remember you want to look for the side and angle that you have that are together, which is going to be B, right? We have angle B and side B. And then let's say we want to look for the other angle that's going to be opposite a known side. So the only other side we know is side C. We don't know side A. So we want to use side C to solve for angle C first. Okay, so we're going to look for angle C, which is going to be, if you're looking for the angle, remember you want to have it on top. So sine C is equal to, or sorry, divided by side C, which is 10. Is equal to sine B, which is sine 56, divided by side B, which is 12. Okay, and so all we need to do is multiply this 10 away from sine C. So we're going to have 10 times by sine 56 divided by 12. Which is going to give us 0.069. And then some kind of an extended decimal there. So now, remember that that's just giving us sine C. So sine C is equal to 0.069 something. So if we want to solve for actual C, then we need to do sine minus 1 of 0.069. is going to be equal to C, which is going to be equal to 44 degrees. If we round it off for the whole number. Okay, so now we know that this one here is 44, and we want to solve for angle A so that we can solve for side A using the sine law. So remember, angle A is just going to be 180 minus 56 minus 44. And again, just use that rounded off number that you used here so that you get a nice even number. And so that gives us 80 degrees. So here you can see I basically drew like kind of like an equilateral triangle. And so this angle doesn't look very different from these two, although these two are more close. And then I have this one being 80. So you can see why it's harder to estimate whether your numbers are correct when you draw your own triangle than it is when it's drawn for you, because presumably usually the triangles that are drawn for you will be at least somewhat to scale. Okay, so now we have angle A is equal to 80 degrees. And the last thing we need to do to solve the triangle is solve for side A. So remember, if you're solving for this side, then it's easier if you put the side on top in your sine law. So it's going to be A divided by sine A. And A, oh, A is, sorry, the one we just solved for, 80 degrees. I was wondering where that number went to. Is going to be equal to, so again, you want to try and use the one that you've been given. So that was side B and angle B. So you're going to do 12 divided by sine B, which is sine 56. And so we're going to do sine 80 times by 12 over sine 56. And that's going to give us side A, which is going to be equal to 14. Make sure you include your unit. Sorry guys, microphone cut out. So use your units that you were given there. So side A is 14 centimeters. Okay. All right, one last one. In triangle PQR, angle P is 41, side P is 3, and side Q is 4.2. So again, we're just going to kind of do a rough sketch here. PQR is how I did this one when I kind of ran through this for practice. So we have angle P, which is 41 degrees. So kind of trying to make it a little bit less than 45. Side P is straight across here, so that's going to be 3 centimeters. Okay, and then side Q, which will be opposite here, is 4.2 cm, and that's side little q. Okay, so the sides that we have, or like the sine law components we have that contain everything we need, which is an angle and a side, is P. Okay, so if we want to start solving this triangle, the next thing that we want to solve for is the component that has one of those two things. So Q, with Q we have the side length but not the angle, so let's solve for angle Q first. Because R, we don't have an angle or a side, so we can't really do anything with that. So with the angle being what we're solving for, we want to start with sine Q on top of our sine law, divided by little q on the bottom, which is 4.2. Set it equal to sine of angle P, which is sine of 41, divided by side P, which is 3. And so again, we're just going to do, let's see, Q is equal to, oh, whoops, actually, sine Q is equal to 4.2. From here, we want to multiply it over, times by sine 41, divided by 3. And that should give us 0.918. Kind of like an extended decimal again. So remember, to solve for angle Q, we need to do the inverse. So Q is going to be equal to sine minus 1 of 0.918 decimal. Okay, and so that will give us Q being equal to 67 degrees. Rounding to a nice whole number so that it'll be easy to do our solution for the next one, which is angle R. So angle R is just going to be 180 minus 67 minus 41, which gives us 72 degrees. So R equals 72 degrees. And then our last one is side R. Side R. Okay, so to solve for side R, remember we want to put the little r on top of sine of angle R, which we just solved for, which is 72, and then set it equal to the one that you were given initially, which was side P, which is 3, divided by sine of angle P, which was 41. Okay, so essentially we're just going to do R is equal to sine 72, which we're multiplying away from the R, times by 3 times by, or sorry, divided by sine 41, which gives us 4.3 centimeters. 4.3 centimeters is equal to little r. Okay, so that's your basic introduction to the sine law. And next time we're going to be looking at, what would that be, 3.3, which is going to be a different law, which is the cosine law. So I will see you in that lesson.